Hello, I am Adarsh Subramaniam and today I am going to explain average, RMS value and form factor along with examples. So let us start. In the study of AC signals, to characterize the magnitude of the voltage and the current, we need different metrics. Three of these metrics are average value, RMS value and form factor. These three metrics helps us to differentiate between AC signals and DC signals in terms of behavior. What is average value? Average value is the arithmetic mean of all the instantaneous value in over a complete cycle. It is used to measure the mean of all instantaneous value of an alternating quantity. This is the formula for the sinusoidal waveform average value. It is average value equal to 1 by t integral 0 to t v of t dt, where t is the time period and v of t is the instantaneous voltage. For sinusoidal waveform, we have derived that the average value is equal to 2 by pi into the peak value Vmax. Vmax is called the peak value of the sinusoidal waveform, maximum value. Example for average value. For a sinusoidal waveform, let us say that the maximum value of voltage is 100 volts. Then the average value will be equal to 2 by pi into the maximum value Vmax. So equal to 2 by pi into 100, 63.66 volt. We have found out that the average value is equal to. Now we come to a new term, RMS value, which is full form of RMS is root mean square value. The RMS value tells us the equivalent of a waveform represents the equivalent DC current which will produce the same amount of power as AC signal, as AC waveform. So it will deliver same amount of power to the load. Mathematically now it is equal to the square of the mean of the square root of the mean of the squares of all the instantaneous values over a complete cycle. For sinusoidal waveform, we have derived that the RMS value is equal to whole root 1 by t integral 0 to t v of t whole square dt, where v of t is instantaneous value of voltage. We have derived that for a sinusoidal waveform, RMS value is equal to V max by root 2, where V max is the peak value. Example, let us take for a sinusoidal waveform. Peak value, let us say, is 100 volts. RMS value we know as 100 by root 2. So we get it as 70.71 volts. Now let us compare average and RMS values. Our average value is the arithmetic mean of the waveform. It gives us the arithmetic mean of all the instantaneous values. RMS value measures the equivalent DC current which would produce the same amount of heat to the load as AC waveform. And for sinusoidal signals, we have found out that the RMS value is always greater than the average value, because RMS is V0 by root 2, which is greater than 2 V0 by pi for any peak value. Now let us come to a new term, that is form factor. Form factor is the ratio of the RMS value of the AC signal alternating quantity to the average value of the alternating quantity of a waveform. It gives us the shape of the waveform. It provides with formula for form factor. RMS value by average value we know is the definition of form factor. Now for a sinusoidal waveform, the form factor is always constant. How? V naught by root 2 by 2 V naught by pi, which cancels out V naught giving us pi by 2 root 2. Pi by 2 root 2 we have calculated as approximately 1.11. Why we need form factor? It is useful for comparing the different types of waveforms. It gives us provides us a way to see the shape of the waveform. For sinusoidal waveforms, the form factor is constant as we have known. V naught cancels out. But for other signals, non-sinusoidal, it can vary significantly. A high form factor indicates sharp peaks, whereas a low form factor suggests that we have more rounded peaks. For high means more sharp peaks. Now let us take example for sinusoidal waveform. Peak value 100 volts, average 2 V naught by pi, 63.66 volts, 100 into 2 by pi. And form factor we have found out RMS by average first, let's say. RMS is V naught by root 2, which is 70.71 volts. And form factor is greater than 1 and constant for sinusoidal waveform 1.11. Now for a square wave. Peak value 100. Now for a square waveform, all three are equal. Since why? Because the waveform is constant. So RMS, average and peak value, all three are same, 100 volts. Form factor is equal to 1. Since average and RMS value of a square wave are same. So form factor 1, average, RMS and peak value, all three are the same. Now graph of a square wave. The square wave has a flat, non-varying shape, so its average and RMS values are equal. Flat, non-varying shape. Triangular wave. For a triangular wave, the only difference between triangular waves and sinusoidal is that the root mean square value is V naught by root 3, not root 2. So peak value 100, RMS is V naught by root 3, not root 2, so it is 57.74 volts. Average value is 63.66, same 2 V naught by pi as the sinusoidal, and form factor is less than 1. It's lesser for it has more rounded peaks than high peaks. Less than 1, which means that RMS by average it's less than 1. It has sharper transitions compared to sine wave, which results in a lower form factor. It has sharper transitions. Now we have given this table which gives us the different waveform type, peak value, RMS value, average value and form factor. For different waveforms we are calculating the different values. Peak value we have taken as 100 volts for all the three waveforms. So for sinusoidal, peak value 100, RMS is V naught by root 2. We know that V max is the peak value 70.71. Average is 2 V naught by pi, 63.66. Form factor is 1.11. For triangular wave, we know that RMS is V naught by root 3, 100 volts. RMS V naught by root 3, which is 57.74. Average is same as sinusoidal, 2 V naught by pi, 63.66, and form factor is less than 1. So it has more higher transitions compared to sinusoidal, 0.91. Square is equal to, all three are same, peak, RMS and average, since the waveform is constant, and the form factor is equal to 1. Now we have reached the end of our slideshow. We have understood most of what is the average, RMS and form factor, and let me give you a summary. Average value gives a basic measure of the waveform, but it is not useful for calculating power. It just gives a basic measure of waveform. RMS value on the other hand is different. It gives us crucial for power calculation, as it represents the equivalent power DC signal and AC signal. Form factor helps us in identifying the different waveform shapes, and it's the ratio of the RMS to average value. Form factor, it gives us the waveform shapes, and we know at the end that different waveforms, square, triangular and sinusoidal, have different values of form factor, RMS and average values. Thank you.